Hello everyone, welcome back to my channel. My name is Ramesh. In today's session, we are going to discuss about Java Singleton design pattern best practices. This is one of the most important and common interview question. Let's check it. How many ways we can create Singleton design pattern. Singleton design pattern restricts the instantiation of the class and ensures that only one instance of the class exists in the Java virtual machine. The singleton class must provide a global access point to get the instance of the class. And another principle is singleton pattern is used for logging, driver objects, caching, and thread pool. Singleton design pattern is used in other design patterns like abstract factory, builder, prototype, and facade design pattern. And Java's singleton design pattern implementation, it has to follow these three principles. Private constructor to restrict the instantiation of the class from the other classes. Private static variable of the same class, that is only the instance of the class actually. Public static method that returns the instance of the class. This is the global access point for outer world to get the instance of the singleton class. And first approach is eager initialization. And in eager initialization, the instance of the singleton class is created at the time of class loading. The drawback of eager initialization is that the method is created even though client application might not be using it actually. This is the drawback of using eager initialization. Let's check it an Eclipse tool. Initially we are creating object, okay? Before method called actually we are creating object and just returning the instance of that one. For that, I'm going to create new class called singleton demo, singleton, singleton demo, okay, which is having main method. Let's delete this one, okay. So now just copy this and the method one, okay, okay, eager, eager method, eager initialization, okay, and private, okay, static, static. Okay, this one and instance is the one you need to create it now to in a variable. Now we are creating object actually initially, okay, and second principle is private constructor we need to use it, right, and constructor has same name as method name, we know that. And third one is public static, okay, and get instance is the method actually we need to create it. So now what we need to do is just this will return the instance, okay, just will just simply return the instance. This is the method actually we need to use first method because unnecessarily we are creating object in the time of class loading, hence we are just not it will be not preferred actually. And just create this instance and just copy this and comment out the first one. And second approach is using second approach, right? Second approach is this one, okay. Static block initialization. Static block initialization implementation is similar to the eager initialization, except that instance of the class is created in the static block, and that provides the option to for exception handling. Only that is exception handling. We're just getting it, okay. Yeah, for now, what you can do is just comment out this code, okay, and rest of the things are fine, okay. Now we need to give static block. In static block, just keep try and then catch block, you need to use it, exception, right, okay. Now what we need to do is here you can just check it like if instance is equal to null, then you are creating object here, okay. Now new instance equal to new object, okay, this object, right, you need to create it, okay. This is the another way of creating. And here we need to provide another throw new runtime exception, of here, like issue occurred while creating, okay, singleton object, okay. This is the another principle, just we are going to get it actually. And there is again there is a problem here. See here, actually, except there is this one, right? Like unnecessarily we are creating, like, so in the he object here, okay. This is the also, like, static block at the time of, like, class loading. This object will be created actually, okay. And third principle is lazy initialization. Lazy initialization method is to implement the singleton pattern, creates the instance of the class global access method. The preceding implementation works fine actually in case of single thread environment, but when it comes to multi-thread environment systems, right, it cause the issues like multiple threads inside the if condition, okay. And at the same time it will just, destroy the singleton pattern, and both threads will get different instances. This is a drawback of using, like, lazy initialization. Let's check it, like, another way, okay. For that I'm going to just okay, just comment out this one, okay. Comment out this one. Now I am just creating lazy loading, okay. So now for that I am just what I am going public static, okay, the name and get instance method we need to create it, right. Here we are checking actually, just return the instance, okay, return the instance. Now what we need to do is we are just checking actually whether object inst is null or not. If it is null, then we are creating instance equal to new object creation, okay. This is the object creation. Another way of creating lazy loading, okay. Again, there is a drawback we discussed, right, for this one, but this approach also we are having drawback, okay. Just remove this here and put semicolon, okay. Just to avoid that one, we need to use thread safe singleton. A simple way to create the thread safe in singleton class is to make the global class method synchronized, so that only one thread can execute this method at a time. Here is the implementation for this one. Only we need to just use this synchronized keyword actually, okay. Just here synchronized keyword, that's it. Only it will allow one thread at a time, and just it will just, avoid the thread conflicts actually. Here also, like, there is some issue, okay. So the preceding implementation works fine for the thread safety, but it reduces the performance. Performance is the major criteria, right, because of the cost associated with the synchronization method, because only one method will allow at a time actually, okay. Although we need to use it only for the first few threads, that might create the separate instances. To avoid the extra overhead every time, double checked locking principle is used. In this approach, the synchronized block is used inside the if condition. If the additional check is to ensure that only one instance of the singleton class is created actually. The following snippet will explain the double checking, okay, locking principle. What we are doing is initially, just this is the method. Initially we are checking if condition and synchronized block. Just, again we are checking the actually if object is null or not. Okay, just avoid this one. I'm just going to comment this part, okay. This part also commenting it. Now creating another principle actually. Public static, this one, right, okay. Public static, and copy this class, okay. Copy this class and get instance is the method we are creating it, okay. Now return instance, okay, return instance. And now what we are doing is if instance equal to null, then I'm just synchronized, okay, synchronized of object dot class. I need to use it. Once again I'm checking it, double principle, okay. If object is this instance equal to null, then only, like, instance equal to new object I'm creating it, okay. Okay, there is a typo, synchronized of instance, okay. This is the double check, and finally we are returning the instance. Public static single demo, and this is the method we are getting, okay. So if instance equal to null and synchronized of single this block, okay. Initially we are checking if object is null, then we are just entering again once again we are checking actually if instance is equal to null, then only we are just creating the object actually. Let's check it, like, how many instances it will create, okay. Here I'm just going to add dot get. We know that like but static methods we will call directly without creating object actually. Okay, just put it like inside the sys out and see. Okay, just close this one and see how many objects it will be created. No further. See, only one object is created. And I'm just calling create one more time. Okay, then also I will just get the same object. Okay, let's check the normal principle. Like I'm creating just one sample class test. Okay, let's see how many objects it will be created. Okay, I'm not creating any methods over here. Just I'm checking, creating one object test equal to new test, new test. Okay, and creating another object test2 equal to new test, same object with a different object notation, right? Okay, sys out I'm just printing it. Let's print the test object and another sys out. Let's print the another test2 and check it how many object it will get printed. See here, two objects are created. This is light hexadecimal format b3 and cc, but in our case singleton class only one object is created, bbb7, and the other object hexadecimal format also same actually. Okay, this is how like we need to test it. Out of these five approaches, the best approach is this one actually, because it will checking double locking principle actually. Okay, this will first initially it will check instance is null, then it will go on inside the synchronized block. Again, once again it will check before create actually object, any object. Okay, three principles we need to remember it. Okay, again this is the best approach, double checking locking principle. And three principles we need to remember. One is private constructor, it will avoid the class from the creating another object actually. Okay, and the second thing is private static variable we need to create it. Another one, public static method we need to create, which returns the same instance of the and it will provide the global point of the access to outside world. Okay, this is all about like singleton Java design pattern best practices. If you like the content, please like this video, share with your friends, and comment if you have any doubts, and subscribe my channel for more interesting videos. And in next video we will come up with a new different topic. Thank you.